So what is a mixture? Mixture can be separated by physical means. Compounds separated only by breaking down their chemical bonds. Mixtures can be heterogeneous or homogeneous. Compounds are only homogeneous. So what is an example of compound? Like a toothpaste. So they can only be separated by chemical reactions, right? So you cannot really take the toothpaste and separate those chemicals somehow, right? So you need a process. You need chemical reactions in order to separate them. But mixtures you can separate by physical means. And mixtures you can actually see them, right? So let's say sand in water. So you can pull out the sand or metal particles in the water. So you can pull the metal from the water. So that's a mixture versus a compound. That's a very visual and simple example. There's more complicated, obviously, mixtures and compounds, but so the compounds, homogeneous, that you cannot tell one thing from another, and the mixtures can be both homogeneous or heterogeneous. So compounds separated only by breaking down their chemical bonds. Mixtures can be separated physically, sand in water. Mixtures could be both, but compounds are homogeneous. So, types of mixtures. So there's solution, suspension, and colloid. So the mixtures could be both, right? Compounds, not here. We're talking about mixtures. So the mixtures, homogeneous mixtures, form when one substance, solute, remember solute, enters the reactions, present in smaller amounts. And that solute, in this case, would be sodium chloride, dissolves, not melts, dissolves, separate, right? Sodium chloride, dissolve or dissociation. Sodium chloride dissociates. In this state, which is, we can also refer to sodium chloride as a salt. We can also refer to that as an ion. We can also refer, not to this one, but to this one, electrolyte, right? Electrolyte, because it has a charge. Ions. Ions have charges. This is ion. This is a salt. Yeah, let's put it here, salt. Salt is something that can dissociate or dissolve in a substance, in a solution, water. Right? If you take sodium and it dissociates in water, the water separates this molecular structure. Oxygen, partially negative, would be hanging around positive. Chloride is negative, would be hanging around positive hydrogen, right? Water did not go anywhere. Positive, close to negative, negative, close to positive. That's a mixture. You can separate it by physical means. Physical means not really taking your hands, taking pieces of metal or the sand taken out of the water. Right? Please understand that. It's not just physically. Yes, you can remove it physically, but you can evaporate water. Right? You take salt, you put it in the water, and then you evaporate water through the condensation reaction, through condensing, right, vape. Evaporates, water evaporates, you cooling off, and then becomes water. You remove water from here by condensation reactions, removing this. Now it condensate, now you can actually see the water, and what's going to happen? Sodium chloride will go back. Right? And now again it is a salt, neutral. Salt, not the table salt, something that can dissociate or separate in the water, we call it salt. Hydrochloric acid, the acid in the stomach, hydrogen and chloride can dissociate in water. It's also salt. So salt is not a table salt that we're accustomed to look at that, but in this case, sodium chloride, it's a crystal in its dry matter. So by removing water, you have a neutral molecule, sodium chloride. By adding water, you separate it into sodium and chloride, and they will take their respective charges, what we see on the periodic table. Sodium positive, chloride negative. Sodium would be around oxygen, chloride would be around hydrogen. You remove water through condensation, and then become chloride and sodium, they go back together, and they become a crystal, salt. So salt, electrolytes, and ions are pretty much the same thing. Ions have charges, electrolytes have charges. Electrolytes can conduct electrical current in the system, in our body. Muscle contractions, nerve cell conductions, calcium positive, magnesium positive, potassium positive, sodium positive, chloride negative, phosphate group negative. So they conduct electrical currents for muscle contractions and nerve cell conductions. We'll discuss this in the nervous system. So the ions have charges, electrolytes can conduct electrical currents, and the salt, something that can dissociate in its respective elements. So mixtures can be separated by physical means, not with the hands, but with chemical reaction usually. So homogeneous mixtures formed when one substance, solute, dissolves in another substance called a solvent, and usually present in the greatest amount, which is water, right? Solution. That's the definition of that. Substance cannot be distinguished one from another. Here, this is the substance, that's your solution. Molecules remain evenly distributed. Sodium chloride dissolves in the water. Sugar dissolves in the water. We say melt, but technically, chemically, it's not melting. To melt sugar, what is sugar? Glucose. To melt this thing, I don't remember, but you need a higher degree. If I'm not mistaken, it's like 181-ish degree of Celsius in order to melt. I could be wrong, right? So I don't want to use that, right? But so melting is something different than dissolving. Suspension. This is the suspension. You see the particles? They can precipitate to the bottom, so you can really see them. So the suspension is heterogeneous mixture. Particles are separated from the material, but they can precipitate. Materials in which they are dispersed and contain large visible solid particles that may settle to the bottom. That's a suspension. So example, not really you can, red blood cells, sand in water. You can really see sand in water, right? But we're talking about the human body. So the red blood cells, can you really see them? No. But if you will take a red blood cell and you put in a test tube and you centrifuge that, so the red blood cells will start breaking down, like proteins or whatever is in the blood will start precipitating to the bottom. And then under a microscope, you will be able to tell the difference, one cell from another cell, white blood cell from the red blood cell, from the platelets, and some other chemicals that are present in the blood. So that's a suspension. Colloid or emulsion. Colloid, heterogeneous mixture. Example, blood plasma, red blood cells, not the blood, red blood cells precipitate. Because when we say blood, the column of blood has formed elements, which is the red blood cells, white blood cells, platelets, and has a plasma, which is water with some other substances, with some hormones, nutrients, and some other substances. We're going to get to that when we get to that chapter. Right? So the blood plasma. What is blood plasma? Again, something that is not the red blood cells or white blood cells, but it's mostly water. So let's say this is 45% of the blood, and this is like 55% of the blood. Percentages doesn't really matter here. Hypothetically, not really, hypothetically, this is pretty much half and half. of the entire blood. So half of the blood is water, half of the blood is the red blood cells. But that half of the blood that is water, most of that is like 90% is water. So, but we'll get to that in later. So colloid is a heterogeneous mixtures. Molecules do not dissolve, like here, they're not separated, they stay intact, and not evenly distributed, have electrical charges, ions, and repel each other. Positive, negative attract each other, but there could be, let's say, calcium, positive, magnesium, positive, right? So the positive, positive repel, negative, negative repel one another. Translucent milky do not settle down. Butter, milk, whipped cream. You look at that substance, it looks like it's one homogeneous mixture, but it's not homogeneous. Under the microscope, it would be heterogeneous mixture. Homogeneous would be this one. They really dissociate, they really separate. Here, they do not dissolve. Here, they do dissolve with the solutions. With the colloid, they do not. Blood plasma looks like it's one substance to the naked eye, but under a microscope it looks different. Butter, milk, and whipped cream. If you look at those substances, there are vitamins and minerals. Vitamins and minerals altogether, macronutrients, carbohydrates, proteins, and fats within butter, milk, and whipped cream. You have different charges. They will repel one another, so it will look like that, murky.